Hello friends, welcome. Friends, today I teach average acceleration. First of all, we understand definition of acceleration. The definition of acceleration is the time rate of change of velocity for corresponding interval of time is called average acceleration. Means average acceleration is equal to change in velocity upon time interval. Friends, average acceleration it is denoted by vector A, and average acceleration vector A of the object for time interval delta t moving in xy plane is the change in velocity divide the time interval. Means according to this formula, according to this equation, we can write down vector A is equal to delta V upon delta T. But here now we take two components of the velocity, x component and y component. So instead we can write down here Vx I caret plus Vy j caret upon delta T. And now we separate them. So we can write down delta Vx upon delta T I caret plus delta Vy upon delta T j caret. Friends, again, according to definition of acceleration, delta Vx upon delta T means acceleration. So now we take here it is denoted by Ax. Ax is a x component of the acceleration. Same way, delta Vy upon delta T, we can write down Ay. So, here Ax and Ay are two components of acceleration. Next question. Explain instantaneous acceleration. The acceleration means instantaneous acceleration is the limiting value of average acceleration as the time interval approach 0. Means now we take limit delta t tends to 0. Friends, now when we remove limit delta t tends to 0, at that time delta is converted into small d. Means we get vector A is equal to vector dv upon dt. Okay? Otherwise, suppose instead delta v, now we take two component of the velocity, means delta vx I caret plus delta vy j caret. So first of all, this value is substituted in here, and I caret and j caret, first of all we can write down, means I caret limit delta t tends to 0 delta vx upon delta t plus j caret limit delta t tends to 0 delta vy upon delta t. Okay, here now limit delta t tends to 0, now we remove it. So here we can write down dvx upon dt I caret plus dvy upon dt j caret. Again, according to definition of acceleration, we can write down dvx upon dt is equal to ax. Look here, dvx upon dt is equal to x, and dvy upon dt is equal to, now we take ay. So we get vector A is equal to ax I caret plus ay j caret. Look here, in xy plane, one particle is moved, its path is curved. At that point, now we want to find out its velocity. So now we draw one tangent. Look here, this is tangent. And this is a y component of velocity, this is a x component of velocity. So Equation 1 represents the differentiation of the velocity with respect to time gives acceleration. Means acceleration A is equal to dv upon dt. Here we can write down velocity is equal to distance upon time. Means instead we can write down dr upon dt. So we can say that d square r upon dt square. Means vector r double dot. Double dot means 2 times derivative of the r with respect to time. Look here, equation 3 represents that the double differentiation of the position, otherwise displacement, with respect to time gives acceleration. Friends, first of all, now we show, look this graph after we discuss it. Look in first graph, this is a P point, here velocity is V, and P1 point, its velocity is V dash. Okay, in second graph, here P2 point, its velocity V dash, here P3 point, its velocity V3 dash, means otherwise V dash, and that point, again, its velocity is this. So we move from P1 to P3, we get different direction of the velocity. Look here, P present the position of the object at time t, and P1, P2 and P3 position after time interval delta t1, delta t2 and delta t3 respectively. In each case of delta t, delta v is obtained using the triangle law of vector addition. By definition, the direction of average acceleration is the same as that of delta v. As delta t decrease, the direction of delta v change, and consequently the direction of the acceleration is also change. So finally, friends, we get average acceleration is also called instantaneous acceleration. And next question, last question is, derive equation of motion of body moving in 2 dimensions. And this equation we learn in third chapter. Again, now we repeat it. V is equal to V0 plus AT, and vector R is equal to vector R0 plus vector V0t plus 1 by 2 GT square. Otherwise, AT square. Here G for gravitational acceleration and small a is only for acceleration. Consider the particle moving along xy direction with constant acceleration a at time t. The velocity is initial velocity is v0, at time t is equal to t, velocity is v. Look here, first of all we describe this figure. Look here, on x-axis now we take time, and on y-axis now we take velocity. Here v0 is the initial velocity and v is the final velocity. Here this is the acceleration. Means, look here, this is the v minus v0 is a change in velocity, and for time he taken is a small t. So friends, first of all, according to definition of the acceleration, we can write down acceleration is equal to change in velocity upon time taken, means t. So we get our first equation, average v is equal to, otherwise vector v is equal to v minus v0 upon t minus 0, means vector a is equal to vector v minus vector v0 upon t. This t is move left hand side, and this minus v0 move left hand side, so it is convert at plus. So we can write down vector v is equal to vector v0 plus vector at. This equation is right in two component, means x and y. So we can write down vx is equal to v0x plus axt. Same way, y component of the velocity vy is equal to v0y plus ayt. Let time t is equal to 0, the position vector of the particle is given by vector r0. And at time t is equal to t, it is vector r. And the average velocity in time t can be given as vector v0 plus vector v divided by 2. So displacement in time t is given by average velocity into time. This is a formula for the displacement. So displacement, it is denoted by vector r minus vector r0. And average velocity, look at this is the formula for average velocity, v0 plus v by 2 into t. Look here, now we have formula v is equal to, look here, v is equal to vector vector v0 plus at. This value of vector v is substituted here. So we get, look here, v0 as it is. Instead we can write down v0 plus at divided by 2 into t as it is. So v0 plus v0 means 2v0. So here we can write down 2v0 plus a. Look here, t is by mistake. Here something mistake, t is required 2v0t because t is multiply. Okay, and 80 square by 2 means 80 square by 2. So friends, 2 are separate, so 2 cancel. So we get here v0t plus here we can write down 1 by 2 80 square. So vector r is equal to vector r0 plus v0t plus 1 by 2 vector 80 square. Suppose this equation we can write down in two component x and y. So instead r we can write down here x. So we get x is equal to x0 plus v0 xt plus 1 by 2 axt square. Same way, y is equal to y0 plus v0 yt plus 1 by 2 ayt square. So friends, these equations are very useful. So you write and prepare it.